Hi, I'm Cleo. Welcome to my math tutorial today. And today we are going to be going over number classification, and we are going to learn how to classify numbers according to their characteristics and what are some of the practical applications of this concept. Now, here's the vocabulary for this lesson. So we will be going over complex numbers, imaginary numbers, real numbers, rational numbers, irrational numbers, integers, whole numbers, and natural and/or counting numbers. So the first one we're going to go over is complex numbers. Now, these numbers are the most general category of numbers, and they consist of all numbers. So they always consist of both a real number and imaginary number. So if you look over here, A is going to be our real number, and B is going to be our imaginary number. So B can be, say, 8, and then it'd be something like I, which is the square root of a negative number. Now, since we went over that, we're going to jump to the next one. Imaginary numbers. Now, imaginary numbers are the square root of a negative number. Now, real numbers are any value that represents a quantity along a number line. So, it's something that you would see on the number line when you were a kid. So, remember that's that line they put like -2, 4, 0, and then 1, 2, 3. Actually, I think I said that out of order, but you get what I'm saying. So, these include numbers that are simple ratios, can't be written as a simple ratio, negative whole numbers, 0, and whole positive numbers. Now, an irrational number is a subsection of real numbers. These numbers cannot be written as a simple ratio. Now, this includes what they call non-terminating and non-repeating decimals. Now, you're going to ask, okay, so what is a non-terminating decimal? Non-terminating is a really fancy word for it doesn't end. It just keeps going and going and going. And what they mean by non-repeating is that the numbers don't repeat each other. So instead of saying 0.333, it would be something like 0.4978278. There's no pattern, nothing. So since they don't have a pattern, this shows that these numbers can continue to divide endlessly with no repeating digits, thus they can't resemble a simple ratio, which is a fraction. And so a good example of what a rational number would be pi. And so one of the things is, technically they say, okay, well, pi can be shown as 22 divided by 7. But technically this doesn't equal the actual variable value. So I'm going to demonstrate this in a second. Okay, so here's my calculator. We're going to go 22 divided by 7 and we'll see what we get. So as you can see, I get 3.142857. So you see none of my numbers are repeating. There's no real order to this in any way. So thus it's irrational. Now, take a look at this one, and we're going to compare it with what they say pi is. So as you see, I get two different numbers. So technically, I can't show pi as 22 divided by 7 because technically they don't give me the same answer. So now we're going to go over what a rational number is. So compared to irrational numbers, rational numbers are numbers that can be written as a ratio of two numbers, which is essentially a fraction. Now, these can include some non-terminating decimals, but the difference is that they have repeating digits. So for example, 1/3 divided it together, you're going to get 0.33333 repeating. So next one we're going to talk about is integers. Now integers include whole negative numbers, 0, and whole positive numbers. Whole numbers. These include positive whole numbers and 0. Now there technically is some debate over if 0 is actually considered a whole number or a natural number, and some people said it's supposedly based on what type of math you're doing, and it depends on which site you go to and who do you talk to. But when I learned it, they always said that 0 was a whole number. So we're going to go with what I learned. So next one is natural numbers. These are the last ones. So what is a natural number? These are numbers that are non-zero positive numbers. And they also are called counting numbers. So these are the ones that you start learning out when you're little. 1, 2, 3, 4, 5. Now, probably if you've studied this subject in school, you probably have seen one of these nasty Venn diagrams. So it can get kind of confusing because, I don't know, they're just very busy. So as you can see here, we got complex numbers, which is everything, and in part of the complex numbers, we have real numbers, which consist of all the stuff in the inside. So we have rationals, irrationals, integers, wholes, and natural numbers. Now, imaginary numbers are kind of on the side here. Are they a part of this complex? Yes. Are they part of anything else? No. So I kind of hopefully came up with a different way to consider this concept. So I'm a very visual person, so I thought about considering it using donuts. And I know that sounds really crazy. So we're going to go over the vocabulary in reverse order to what we just went over it. So first of all, we're going to start with our natural numbers. So these are kind of our base, like our basic donut, because these are the numbers that we start with, which are like 1, 2, 3, 4, 5. Now, we're going to go on to whole numbers. Now, whole numbers, as you see, they include our basic donut, so 1, 2, 3, 4, 5, 6, 7, 8, but they also include 0, which are kind of like the pink icing. Now, we have integers. Now, integers include all the stuff that we had in whole and counting numbers, thus the pink icing and the plain donut, but they also have sprinkles, which are an analogy to my negative numbers, and I kind of picked these because technically sprinkles kind of look like negative signs. Okay, next. Now, rational numbers, I kind of represented these as donut holes. Now, why I picked donut holes is technically donut holes can be shown as a part of a bigger donut. Very much like rational numbers can be shown as a fraction of numbers. Now, irrational numbers are kind of like donuts with filling. Now, if you take a donut with filling and you cut it into pieces, all of the filling comes out, which you don't want. So, irrational numbers are like donuts with filling because they can't be cut into pieces. Just like irrational numbers can't be shown as a fraction, or they can't be shown as sort of like a cut up version of a whole number. Now, real numbers are all of these lovely things here. So it's kind of like you consider donuts. So they include all of this stuff. Now, we're going to go over to imaginary numbers. Now, imaginary numbers are all in their own little category. So they're completely different from everything else. So to sort of conceptualize this, I made it a narwhal melon bud. Now, for some reason, this one doesn't have the horn, but the next one does. Now, complex numbers. These are pastries, so they include all of the stuff we just went over. Now, see, this guy, he has his horn now. Okay, hopefully that makes sense. Now, kind of hopefully that donut analogy makes a little more sense. So, as you can see, it sort of adds on together instead of the Venn diagram. Now, we're going to have some questions to test your knowledge. So, here's a question. Now, what category do these numbers fall into? So we have 1, -2, 1/2, and 0.12334. Alright, I'm going to give you a second. Alright. Okay, everybody ready for the answers? Alright, here we go. So, 1 is technically a natural number because it is a whole, non-negative, non-zero number. -2 is an integer because it's a whole, non-positive number. 1/2 can be shown as a ratio of two numbers. And 0.2334 is a non-repeating, non-terminating decimal that doesn't have a pattern, so technically it is an irrational number. So now we're going to go over, okay, how can I use this classification number in a practical way? So I'm going to be going over some really basic Python programming so that you can kind of gain an idea of sort of why this is important. And why I'm including this is when I was in math class, I always got annoyed because we would learn things and they would say, okay, you got this, now what do I do with it? And many of the teachers really didn't have an answer to it, so part of the series I'm going to try to come up with some sort of practical application for those of us who like making things can apply this into our everyday creative processes. Okay everyone, so I went ahead and I opened up my Python compiler. So first of all, one thing I want to show real quick is I want to show the concept of how in Python numbers work. So they kind of classify them a little bit differently than we do in math, but it's not a whole lot different. One of the important things to know about programming is you really need to know and pay attention to what integers are. So real quick, I'm going to run through here. So basically what this program does, it's very simple. I just basically assign all these numbers a value, and when I print these in, it's going to tell me what kind of value they are. So I'm going to run this real quick. So as you can see here, this one is an integer. This is an integer. And this guy here is what they call a float number. So anytime when you're thinking about sort of like what we just learned is a rational number, in Python it's considered what they call a float. Now I'm going to go over this real quick. Now, technically these are what they call a for loop. So basically what you need to know about this is you cannot use non-integer numbers in getting these to work, in Python 3 anyway. So let me explain. So take a look here. If I take this and I put in 5, and so basically what this is supposed to do is when they say range, it says 5 and 10. So it's going to technically start at the number 5 and it's going to go to 10 minus 1. Now the minus 1 is just kind of a weird thing that just runs with this particular language, but it'll make more sense. And then what it does is it just going to print out those numbers. That's what this whole thing does. So let me show you. Hit run. So as you can see, it printed out 5, 6, 7, 8, right? Now, as you can see, it works. I don't get an error message. Awesome. Now, let's say I was to put in some sort of float or integer number. So let's say I put 5.7 and 10. I don't know, 6. Alright, now I'm going to run it now. Let's see what happens. Now, if you take a look here, I get an error message. You see, and it says, type error, float object cannot be interpreted as an integer. So, as you notice, see, integers are important. So, why are you showing me this? So, I just wanted to show you a practical application. When you're doing programming, it's important to understand what type of numbers you're looking at, what's a classification of them, because you can make really silly mistakes and it can cause your program not to work if you don't put the right kind of number in it. Okay everyone, that pretty much wraps up my tutorial, and thank you if you have gotten this far in and you have not clicked off for watching. And here is my social media accounts. I've just created these. Here's my Twitter and here's my Instagram. Please go on one of these and give me some suggestions on some topics that you think you would like me to cover. There's a lot of stuff out there with math. I generally go up to Algebra 2. I did take calculus, but honestly, I don't remember enough of it or comfortable enough to do a tutorial on it. So if you have anything between that areas that you would like me to go over, leave me a suggestion at one of these two places. And here's my sources for this video. I will be leaving a link of sort of a bibliography that I did with all my sources. And all of my lovely kitchen clip art that I got this is from Digital Artsy Etsy shop. So please go and check her stuff out. It is really cool and it is very inexpensive and you can get some really cool clip art. to put in your videos or other things that you do. And once again, thank you!